picking up where the other class left off. Make sure I'm not on this time. But I do want to go over question number 17 again. Now, question number 17, this is coming from lesson 16, finding slopes and equations of lines. Now, as we're looking for for the slope-intercept formula of an equation, what's the very first thing that I want to look for? The y-intercept. Somebody explain the y-intercept to me real quick. Haley.
Where the line passes through the y-axis.
Very good. Where does it cross the y-axis in this question? Negative 4. All right, so as I begin to write an equation for this, I'm going to write y equals, and negative 4 is going to go off over here at the end, right? Because that's why I'm going to put the y-intercept. What goes in front of the y-intercept portion in the equation? The slope. The slope. So here, notice that it's positive. And I'm simply, because slope is what? What's a small definition for slope? Rise over run. All right, so we're going to check our rise to the next coordinate spot where it's going to cross at a point. So 1, 2, 3, 4, 5, 6, and over 1. All right, so if it goes up 6 over 1, my equation is going to be y equals 6x minus 4. Check my answer here. F of x, which is the same thing as y equals 6x minus 4. All right, does that make sense to us? We can follow along on that. Now, the reason I give you the lesson numbers is because, right, it may be a more complicated question for this. Or it may give you the equation of the line and ask you to graph it, right? So just because you see this question on the review doesn't mean that you're going to see the same question type on the test. So we're going to have to move that out of the way. All right, let's keep moving that around. All right, let's see. All right, question number 18 says write the inverse of the statement. If a figure is a square, then it has 4 sides. Earlier on in the review, we covered a question that asked about contrapositive. So in order to understand contrapositive, we have to understand 2 other types of changes in statements, and that's converse and inverse. This one is looking for an inverse. What will an inverse do to an if-then statement? What are the terms for how we break up a conditional statement? Okay, I'm hearing parts of it around the room. I heard the word hypothesis. Okay, what's the other? What goes on the other end? Conclusion. Okay, where this is if my hypothesis, then my conclusion. What does inverse do to my hypothesis and conclusion? Inverse switches them? Inverse negates. Alright? It negates both. Okay? Essentially what we get is, if I shorten this to if A, then B, what does an inverse do? Well, how would I rewrite that as an inverse? No? Sure. Well, if we were going to just do symbols, this would be if not A, or negate A, then a negation of B. Okay, or not B would be any sentence or paragraph that's going into that. Okay? We spell hypothesis. Yes. There you go. You're welcome. All right. So let's go back to our statement where we kind of reviewed inverse, because our natural tendency is to assume converse, and converse is where we flip the hypothesis and the conclusion to opposite sides of the comment. Right? Inverse statement, if a figure is a square, then it has 4 sides. He's pretty confident they know the answer to this question. Because I did go on hard time in Algebra 3, he's going to tell the whole YouTube community what is the inverse of that statement.
If a figure does not have 4 sides, then the figure is not a square.
Is he correct?
No.
What did he do? And he did what? What's the term for that? He found the contrapositive of the statement. All right? We only want the inverse.
I did that on purpose.
as a teaching. Dylan says he did that on purpose, to provide a teaching moment critical to all of you out there in the weather sphere. All right, does anybody want to try giving me the actual answer? Okay, Marissa, for everyone to hear. Yes, actually number 18.
If a figure is on a square, then it doesn't have to apply.
Perfect. Okay. If a figure, it's so hard to put on without looking at it. Okay, if a figure is not a square, then it does not have any sides. I don't need to go into writing that out. All right, let's come.
Yeah, and then I'm going to be the one that tells you this too.
Yeah, in every video, listen to the point where Dylan gets made fun of. Can you find it? All right. A major arc has a measure of 2x plus 50 degrees. A corresponding minor arc has a measure of 3x minus 40. What's the relationship to a major and a minor arc? Billy, do you know? No. It does not. David knows. Marissa knows. Does anybody else know? Okay, David, what is the relationship between a major and a minor arc? Make a full circle. How many degrees are in a full circle? 360 degrees. So what can I do with a major arc and a minor arc to solve for x? Okay, so 2x plus 50 plus 3x minus 40, and because I'm adding, I don't have to distribute the plus. What am I doing here to solve for x? Brenda. Oh, I've left something out, haven't I? What did I leave out? What did I forget? Up to this point. E equals 360. Okay? What's next? Brenda. Okay, give me some like terms to combine. Okay, 2x plus 3x equals 5x. 50 minus 40 equals 10. Positive 10, right? So 5x plus 10 equals 360. What are we going to do after that, Brady?
You're going to subtract 10 on each side.
Subtract 10 on both sides. Very good. So 5x equals 350. What am I going to do to solve for x here? Now Billy knows what to do. David knows what to do. Dylan knows what to do. Savannah, what am I going to do? Divide by 5 on both sides. All right, x equals what? 70. And they're not asking me what, could they have asked me what the major arc was and what the minor arc was? Absolutely they could have. In which case, what would I have wanted to do? Plug 70 in for x into both the major and the minor arc equation. Okay? You want to be very careful on the test of making sure that you've answered the question that is being asked. Okay? So that you don't stop too soon. All right, number 20, law of syllogism. Different than the law of detachment. Law of detachment is based upon major and minor premises. This is, if you remember, if A then B, if B then C, so if A then C, right? That type of thing. So use law of syllogism to draw a conclusion from the given information. So at every comma, we should be able to look at the statement that came before it and determine, we want to label it. This is probably the easiest thing to do. Two lines are perpendicular. I'm going to underline a word that I think is important. The word perpendicular. What should I label that? Let's label it A. Okay? Then they form right angles. What do we think is an important phrase in there, or word, or words? Right angles. Okay, right angles. What do we want to label that? Let's label it B. So if A, then B. Let's come down to our next one. If two lines meet at a 90-degree angle, what should I do? What's important? 90-degree angle, they're showing me. What do we want to call that? We already have a B. B. Okay? Then they are perpendicular. Oh, that's A again. Okay, so, all right, so we have if A then B, if C then A, if two lines meet at a 90-degree angle, what is that? C. All right, so we already know that C equals A. We know that A equals B. What do we need to know? That C equals what? We need to know that C equals B. So our conclusion is, then they are what? Right angles. Boom. Okay? I mean, boom is not hardly more of a statement. Okay. Let's go to number 21. Yeah, the screen is recording. Okay, find the area of the parallelogram. How do I find the area of the color? Parallelogram. Okay. How do I find the area of a parallelogram? Based on side. Is that what you're going to say, Haley?
Based on height.
Length times width, kind of. All right, so what is, hey guys? All right, trying to make this actually useful information. We do need to get through as much of this as we can. What am I multiplying here then if I'm doing based on height? 6.5 inches times 15 inches. And question number 21.
97.5.
97.5, somebody said.
Yeah.
Who knows if that's correct or not? Trying to find the answer here. 97.5 inches squared. He's got it, folks. God goes wild. 97.5 inches squared. They break out into applause. Cheering. Oh, hold on. Lifting me on your shoulders. It's a Rudy moment. Thank you so much. You guys are too kind.
When you start singing like that Jewish song, I can do it for a moment.
I think you're. What is that called? Anyway, all right.
I got you. You keep it quick.
All right. Question number 22. We're getting a proof here. It's pretty simple proof. It's just going through the math. It says simplify the expression, justify each step, fill in the missing justification. We've got. It almost seems like there's missing information to that question. Okay. What? Okay. So yeah. It's actually really pretty basic. They're doing 2 plus 8 plus 6. You're saying that 2 plus 8 plus 6. What have they done here on this side? Because this is what we're seeing. We're going from here over to this. What have they done? They moved to 68. What property allows them to do that? The commutative property of addition. Good. All right. Now, what from here? They're coming down to here. What have they done? What's changed? They put parentheses in. What property allows me to put parentheses around a certain section? The associative property of addition. Very good. All right, I won't need to go into a whole lot more detail there. But number 22, just so you're aware, that is lesson 24 algebraic proofs. So you want to go back and look at that. Like I said, the questions on the test may not be exactly like this. All right, 23. How many questions do we have on this review? 35. 35, so we still got a long ways to go. All right. I think what it's called is, when I lift you up on the chair, is it called the hora?
Hava.
Okay. Yeah, let's get that in maybe. All right, baseball diamond at playground is a square. That's going to be important to us. That measures 70 feet. Okay? Sides measure 70 feet. About how long would a straight line be from the home plate to second base? Find the answer to the nearest hint. Okay, we have a straight line right there. Because a square is also a what? It is a rhombus. Now, what do I know about the diagonals of a rhombus? They're not congruent. They are perpendicular, but that's not going to help me in this question. They do what to opposite angles?
Oh, they bisect.
They bisect opposite angles. If this is a square, what are all my angles? 90. So if I bisect 90 degrees, what am I getting? 45 degrees. You can't see the shade I just threw Dylan in the video, but it was epic. All right. So I know that my side lengths are 70 and 70, which means the length from home plate to second base is what? Now, I don't want the answer, but what do I call that line in this picture? It's the hypotenuse of a 45, 45, 90 triangle. In a 45, 45, 90 triangle, what are my ratios there? 1, 1, 1 radical 2, or x, x, x radical 2. So the hypotenuse here is going to be what in radical form? 70 7b, radical 2.
Yeah.
Okay, we'll make fun of Don for saying 7 radical 2, because you couldn't have heard it anyway. So, all right, so what we want to do is we want to round our answers to the nearest 10, so we're going to plug that into our calculator. We're going to do that right now. Somebody's going to tell me what that is. 2399 feet, folks. You could have done 70 squared plus 70 squared equals c squared. You would still have gotten 70 radical 2, and you still would have plugged that in the calculator, and you still would have gotten 99 feet. And you can have those yourself there. All right. Next question. Find the sum of the interior angle measures by dividing the polygon into triangles, if necessary, around your answer to the nearest hundredth. The sum of the interior angles, they say, by dividing the polygon into triangles, would look something like this, and then this, and this, and then that right there. How many triangles do I have inside that polygon? 1, 2, 3, 4, 5. We're going to take 5 times 180. Dylan said 360. We all laughed at him. Okay, 5 times 180 is what? 900 degrees. Would we have even needed to see the picture to find that out? Would you have a formula, right?
Actually, we need it.
We would need the number of sides. That's minus 2 minus 180 is going to give you the sum of the interior degrees. What if it was a regular polygon? Could I find out what each interior angle was individually?
Yeah.
By dividing by the number of sides or number of angles as well. Oh yeah, regular polygon, right? If it was a regular polygon, then I could have divided by the number of angles that I had to find out what each individual angle would be. You have an earlier question, it's already been covered in the previous video, where it has a 45 asking for what is each individual. It really comes out to something like 172 degrees. But you'll have to watch part 1 to be certain of that. Previously on this lesson. Okay. Let's see. All right, number 25. Number 25 comes from lesson 32, altitudes and medians of triangles. Yay! Okay. BY is 19.8. That is this entire length right here. CO, okay, this segment is 18. We want to find, let's see, AX, BY, and CZ are said to be medians. We want to find BO. Normally we try to avoid BO, but this time we're looking for it. Yes. Oh, yes. It's a simple joke. Don't laugh. Please don't cry. All right. All right. So the relationship, this is what we would call, if I'm not wrong, a centroid, okay? Which means the BO in this case is 2/3 the distance of BY. So I really don't even need 18 in this particular instance, okay? We're going to take 19.8 times 2/3, okay? What do I get? And this is question number 25. 25. What do I get? 13.2. 13.2 is the answer. 13.2 is the answer. Thank you very much for participating. Do we understand how to find this? Now, like I said, whenever we're done with questions that involve centroids, all right, they will not necessarily be this easy. Go ahead. What's your question? Lost his question. This is. Oh, it just keeps happening.
It really does.
All right. 26. NLP is a parallelogram. Find MP. Find MP. It's right there. We found it. What do I know about the relationship to opposite sides in parallelograms? They are congruent. Thank you. So 5x equals 3x plus 12, correct? Alright, so if we're looking for MP, the very first thing we need to do is solve for x, right? So let's subtract 3x from both sides. It's going to give me 2x equals 12. We're going to divide by 2. We're going to get x equals 6. Am I done? No, because it asked me to find x even on x. So we didn't need x to get there. So 5 times 6 is 30. Okay. Let's see, that's lesson 34, properties of parallelograms. You do have 4 properties of parallelograms which you need to know. Okay, number 26, and let's go on down to 27. All right. Moving this on over. Determine if you can use hypotenuse leg, determine if you can use the hypotenuse leg congruent stem to prove the triangle ACD and is congruent to triangle DBA. If not, tell what else you need to know. Well, the short answer is yes, but I do want to talk a little bit about how we get there, okay? What I want you to see, because they don't show me that these are right triangles, but they do show me that I have parallel lines cut by a transversal, which means I know that this is a right angle because I have corresponding angles, right? So I know that that's a right angle, okay? All right, and as I come across here, right, I also know that angle C is a right angle because of corresponding angles, right? 2 parallel lines cut by transversal have corresponding angles that are congruent, therefore make those right angles. Okay, I also know that those 2 triangles share that side, which would mean reflexive axiom, which means I have a leg and a leg. I have a hypotenuse and a hypotenuse. Can I use hypotenuse leg? Yes, because first I've proven that I have 2 right triangles. Then I proved that their hypotenuses are congruent through the reflexive axiom. And I know that their legs are congruent because the tick marks show me that. Okay? All right. Again, because the question may be different than that. So you want to look at lesson 36, right triangle congruent stems. You also want to double back to lesson 12. Okay? All right, number 28. How am I doing on time? How much time do I have left?
Yeah,
15 minutes. Okay, we're on 28. Find the circumcenter of triangle ABC with vertices -2. Actually, you can take that box. Find the circumcenter of triangle ABC that has these vertices. Well, question number 28. Right, these are perpendicular and angled bisectors of triangles. All right. Let's see. Let's go over. Let's dig into our book here a little bit. I want you to look at something. Like I said, this is question 28. I want you to go over to lesson 38. Go over to lesson 38 real quick. Okay, and they're asking what the circumcenter is. So you should find in a paragraph, if it is on the same page, it'll be page 245. A perpendicular bisector divides a line segment into 2 congruent segments and is perpendicular to the segment. And perpendicular bisectors are drawn for every side of a triangle. The point of concurrency is the circumcenter. Okay? So, what you end up doing is you end up looking for the midpoint first, and then you're drawing a line that's perpendicular. So, if we notice on segment AB, for instance, this is 1, 2, 3, 4, 5, 6. So I'm going to go up here, and then I'm going to draw a line that's perpendicular to it. Well, because AB is vertical, a perpendicular line is horizontal. You follow me? Okay. Okay? And BC is horizontal. All right, so I need to find the distance here. 1, 2, 3, 4, 5, 6. So same thing, I'm cut over 1, 2, 3. Get that point right there. And because it's horizontal, a perpendicular line would be vertical. All right, so the circumcenter of a right triangle is actually on the hypotenuse. Okay, so the coordinates for the circumcenter there are 1, 1. Okay, That's where it does you good to go back and look at the book and find out what definitions there are. Things like circumcenter, orthocenter, those are different. Okay? What?
Okay.
That's how we're reading.
I'll put a comment in it, what it says.
Okay. Haley's going to update you on what Dylan said about himself, so everybody. I've got full posterity. So, finding area of shaded region, use 3.14 for pi around your answer to the nearest 10. All we're doing here, if we're looking for area of shaded region, is area of the rectangle minus area of the semicircle. Alright, how about finding the area of the rectangle?
6 times 5.
6 times 5, and that is 30. 30 minus the area of the semicircle. So how do we find the area of a circle?
5 times 30.
Pi times the radius squared. What's going to be the radius of that circle? 2.5 or pi has? Oh, let's just do 2.5. Pi r squared, correct? And because we only want half of it, we're going to divide by 2. We're going to use 3.14 for pi. So this is what it would look like in a graphing calculator. All right, let's turn that on. Clear that out. 30 minus. Okay, I'm going to use 2 sets of parentheses here. Pi 2.5 squared divided by 2. I get 20.18. The answer in your book is 20.2 because we're having to the nearest 10. So that gets me the right answer. 20.2 inches squared. Okay? All right, for question number 29, that comes from lesson 40. Question number 30. Okay, measure angle ABC. We want to compare it with measure angle CDE. All right, we do know that BC and DC are congruent to each other. We're comparing angle ABC with CBE. Okay? Well, BC is congruent to BC, and AB is congruent to BD. So if I'm comparing these, what am I noticing the difference? What's the only difference between those two triangles? The length of AC to CD. Okay? What is that going to tell me about those two angles? What does that tell me about measure angle ABD? Measure angle ABC is what the measure angle CBD. Okay, this one is greater than because it's opposite a side that is longer. All other things being congruent, an angle that is opposite a larger angle will be larger. Okay? Question number 30 comes from investigation number 4, inequalities in 2 triangles. Inequalities. Okay. Make fun of myself. Number 31, find the distance from the center of a circle to a 10-inch chord if the circle has a 16-inch diameter around your answer to the nearest 100, if necessary. This is one that requires some additional thinking. That was a beautiful circle, by the way. You know, a hard time erasing that.
I'm beautiful early.
It's oblong.
Okay, now I'm glad that's recorded for posterity. 12, all right, 10-inch chord. Okay, we're going to call that 10 inches. Okay, has a 16-inch diameter. Now, how many diameters can I draw in a circle? Infinite. Which means there's exactly one diameter that is going to run perpendicular to my chord. I'm going to pick that one. Okay? Because a diameter that is perpendicular to a chord will do what to that chord? It will bisect it. Which means I now know the length of half of that chord, right? What's half of that chord? But 5 what that red line is? Okay, tell me what the red line is? 8, because it is a radius, and radius is half the diameter. Alright, if I know that that hypotenuse is 8, the leg is 5, can I find my distance or green line? My diagonal theorem makes that. So x squared plus 5 squared equals 8 squared. X squared plus 25 equals 64. X squared equals, what do you think? What's 64 minus 25? 39. Okay, square root of 39. X equals, we want to round our answer to the nearest 100. 6.24 inches. Okay. So that's the work that you need to show in order to get that question correct. Okay? That hypotenuse is not a line that they'll give you. We have to make a lot of inferences. Okay? So you want to pay special close attention to this question. All right, number 32. How many questions do we have?
35.
35, so we're getting close. All right, and solve the inequality for x. Okay, well, if I'm solving an inequality for x, I do know one thing. Let's see, this is question 32. Okay, I know that 2x plus 4 has to be greater than 8. How do I know that? Right, and if 2x plus 4 is the hypotenuse, opposite the right angle, what do I always know about the hypotenuse of the right triangle? It's along the side. So 2x plus 4 has to be greater. Now, if I want to solve for the inequality for just x, I'm going to subtract 4 on both sides. So that 2x is greater than 4. I'm going to divide by 2. I'm going to get x is greater than 2. Okay, that's my inequality for x. X is greater than 2. That's less than 42, finding distance from a point to a line. 32? Yeah. Okay. Alright, can you do it? I can. 33 is very similar to one where you just covered up there where we actually have to draw a circle. It says find BD. Okay? Which means I'm going to draw that line right there. Okay? They show me that the entire radius is 10. Okay? I'm going to solve for that guy right there. So 6 squared plus x squared equals 10 squared. 36 plus x squared equals 100. Somebody ask a question? Yeah, where do you get the 10 from? 4 plus 6 is 10. Okay, so that tells me that the radius is 10. AD is also a radius, so they're going to be the same length. Okay? If I subtract 36 from 100, I get 64. So x squared equals 64. X equals, because I'm going to square root both sides, x equals 8, which means BD equals 16. Do not forget, it's not asking for CD, although we need CD to find BD. Alright? A lot of people are going to end up hopefully getting 8 as part of their answer, but we'll stop right there because they're going to see it in that multiple choice section. Okay? Remember, a chord that is met at a right angle is bisected. So double it, the whole chord. 33, let's see. That comes from lesson 43, chord sequence and tangents. Last two questions. A wheel from a motor has spring, and that doesn't really matter. We want to find measure angle DOC. Okay. This is dealing with inscribed angles and intercepted arcs. We want to find measure angle DOC. We can do that a number of different ways. For instance, I know that this inscribed angle is opposite an intercepted arc at 30, therefore it is 15, right? And I have a triangle here that adds up to, I got 20 plus 15 plus x equals 180. Okay, so I've got 35 plus x equals 180, because there's 180 degrees in a triangle. Subtract 35 from 180, comes out to what, 145? 145. All right, because this is 145, This is a vertical angle. What do I know about vertical angles, class? Vertical angles are congruent, therefore DOC equals 145 degrees as well. Okay, that's 34. That's lesson 47, circles and inscribed angles. That's not the only way to solve that question, but it's a pretty good way. Okay? The last question of the day. Okay? Find X, Y, and Z. Express your answers. Let's get rid of that. In radical form. Alright, this is going to talk about geometric means. Geometric means. You can find this information on lesson 50. Okay? Hopefully we remember some things from here. If I was going to find X in this case, what do I know about 5? Well, yeah, it's a line that's drawn from the right angle, perpendicularly to the hypotenuse. If you need to, go back over to lesson 50, which you probably do need to because it seems like we forgot this. Even though we did work this question out in class, lesson 50. Lesson 50 shows up on page, pardon there. Alright, you're looking at page probably 329, starting on page 327. If the altitude is drawn to the hypotenuse of the right triangle, then the length of the altitude is the geometric mean between the segments of the hypotenuse. 5 is the altitude, so therefore it's the geometric mean of the segments of the hypotenuse between 10 and x. So what's 25 divided by 10? 5 times 5 is 25. 25 divided by 10, 2.5. Okay? So now I know the length of the entire hypotenuse is 12.5. Okay? I could go on from there. What else do we know? We know that if the altitude is drawn on the hypotenuse of the right triangle, then the length of the leg is the geometric mean between the hypotenuse and the segment of the hypotenuse that's closer to that leg. So we can do that with y. Set y as the geometric mean. Okay. Let's see. If the altitude is drawn to the hypotenuse of the right triangle, then the length of a leg is the geometric mean between the hypotenuse and the segment of the hypotenuse that's closer to the leg. So the entire hypotenuse is 12.5, and 2.5 is the segment of the leg that's closest to y. So what's 12.5 times 2.5? Come on, guys, help me out. A little louder. 31.25 equals y squared, so I need the square root of 31.25. What is that?
5.6.
5.6, but it wants our answer in radical form. This was what, 31 1/4? Let's try to do that. Let's see if we can leave it. Let's say 31. Let's take that as a 31 1/4. Okay, 4 times 31.
124.
So it'd be 125 over 4. And we would want the square root of that, right? Okay? So it would be 5 radical 5 over 2. Okay, is y. Yeah, this one's not going to be a nice pretty answer. We can do the same thing with z. Keep in mind it may not be a nice pretty answer.
Then you just use the Pythagorean theorem.
You could do the Pythagorean theorem at this point. Okay, but so that you're seeing the principle that they're looking for, it would be z over here, z over here, 12.5 and 10. Alright, so what's 12 and a half times 10 would be what, 125? So 125 equals z squared, so we would take the square root of 125, and if we work that out, it should be 5 radical 5 equals z. Alright, and just so you're seeing that done, we would break it down like this, 5 and 25, 5 and 5, and because it's the square root, we can only take 2, so that's how I get 5 here, and this guy stays right there. So I get 5 radical 5 for Z. That's all of that. Less than 35 comes from less than 50, like I said, if you want to mean. All right. Thank you very much. And like I said, I will get this video out to you as well as the other one as soon as I can.